Every AI lab is racing to build the smartest model, but OpenAI just made a different bet. They built one that's 15 times faster and put it on a chip the size of a dinner plate. GPT-5.3-Codex-Spark is a smaller distilled version of OpenAI's flagship coding model, GPT-5.3 Codex. Think of it like this. The full model is the deep thinker. It works autonomously for hours on complex tasks. Spark is the fast collaborator, optimized for real-time interaction, delivering over 1,000 tokens per second. You ask, it responds nearly instantly. What makes this speed possible isn't just software. It's a fundamentally different kind of chip. Codex-Spark runs on the Cerebras Wafer Scale Engine 3, a single piece of silicon with 4 trillion transistors and 900,000 AI cores. A typical GPU is the size of a postage stamp. This chip is an entire silicon wafer, 57 times larger. By keeping everything on one chip, it eliminates the communication bottleneck that slows down GPU clusters. Here's where it gets interesting. On SWE-Bench Pro, and a benchmark for real-world software engineering, Codex-Spark scores competitively with the full model, around 57%. But it finishes tasks in a fraction of the time. But on Terminal Bench 2.0, which tests more complex agentic coding, the gap widens. Spark scores 58% versus the full model's 77%. That's a 19-point drop. Speed costs intelligence. But the speed story goes deeper than hardware. While building Spark, OpenAI rewrote their entire inference pipeline. They introduced persistent WebSocket connections, streamlined how responses stream from server to client, and reworked how sessions initialize. The result? 80% less overhead per round trip, 30% less per token, and the first visible token appears 50% sooner. These improvements will roll out to all models, not just Spark. OpenAI is positioning this as the start of a two-mode coding future. Mode 1. The full Codex model handles deep, autonomous work, running for hours, solving complex multi-file problems in the background. Mode 2. Spark keeps you in a tight, interactive loop, making quick edits, reshaping logic, seeing results immediately. Over time, OpenAI envisions these modes blending, with Codex delegating to faster sub-agents when speed matters. But perhaps the most significant thing about Codex-Spark isn't the model itself. This is OpenAI's first production deployment on non-Nvidia hardware. In January, they signed a $10 billion multi-year deal with Cerebras for 750 megawatts of compute. OpenAI is diversifying its hardware supply chain. GPUs remain foundational for training and broad inference. But for latency-critical workloads, purpose-built silicon like the WSE3 offers something GPUs structurally cannot. This is the beginning of a split in AI infrastructure. So, should you pay attention to Codex-Spark? The speed is real. Developers confirm it changes how you interact with AI. At 1,000 tokens per second, the bottleneck shifts from waiting for the model to keeping up with it yourself. But the capability gap is also real. A 19-point drop on complex tasks means this isn't replacing frontier models for serious engineering. It's a complement, not a successor. The real story here isn't one model. It's the signal that AI is fragmenting. Specialized models running on specialized hardware for specialized tasks. That infrastructure shift is worth paying attention to.